Alright, we are going to take notes on the evidences of chemical reactions. How do we know it's definitely a chemical reaction? And when we're watching a chemical reaction rather than reading an example, how can we tell? You're going to take notes on your paper that looks like this, and I'll highlight what needs to go on each bullet point as you go. So first one is gas production. We know that for watching chemical reactions, sometimes we get a production of a gas, and that would look like bubbles or fizzing, which indicates the production of a gas. We know producing a gas is a new substance and an indicator of a chemical change. Sometimes when the bubbles or gas are produced, you also get a change in odor. So you'll get a strong smell, sometimes just a faint smell. But if you smell a change in odor, this is often an example of a chemical reaction. So we're going to watch our first example. All right. As you can see in the reaction of baking soda and vinegar, we know it's a chemical reaction just by the fact that there's so much fizzing and so many bubbles that are produced during that reaction. There must be a chemical reaction taking place. All right. The second indicator of a chemical change is what we call a precipitate. A precipitate is a solid that forms spontaneously when two liquids react. This is really an interesting thing if you think about two liquids pouring together to create a solid, basically. We're going to watch an example, which is potassium iodide, element K bonded with element I, potassium iodide, and lead nitrate. Nitrate is NO3, so talking a compound there. We're going to watch those two interact. All right, you could see instantly when one solution was poured into the other, a bright yellow precipitate was formed. So that would definitely be an indicator of a chemical change. Right? The third type of indicator is energy change. Now, without adding or removing heat, so we're not adding any heat ourselves, chemical reactions sometimes spontaneously produce or remove energy. We divide this category into two separate subdivisions, and the first is called exothermic reactions, and that is a reaction that releases energy in the form of light or heat. They feel warm, or they light up, or they evenly spontaneously combust. And we're going to watch an example of an exothermic reaction. All right, here's your exothermic reaction. All right, you can see in an exothermic reaction, two different substances simply mixed together and they react, and in that case released a whole lot of heat and light, and also spontaneously combusted. Sometimes exothermic reactions will just feel kind of warm or a little bit less dramatic, but either way both would be considered exothermic reactions. An endothermic reaction is the opposite. It is a reaction that absorbs energy, so therefore it feels cool or cold in temperature. I have an example of an endothermic reaction as well.
So that must be the barium, doesn't smell. Ammonium compound smell. They're both solids, okay? They're both white solids. Powdery, there's the ammonium nitrate and there's the barium hydroxide. I'm going to mix these two together. Hopefully I can get it all in there. Let's go in. Put the top on because it generates ammonia, which stinks. So I'm just going to mix it around. It's an unusual reaction in that it's two solids reacting with one another. You don't see that very often because the point of contact between the two solids is very small. The spheres touch each other at a point, whereas two gases can completely dissolve in one another, and so you get a lot more reaction going on. But in some cases, two solids will actually react with one another. So as this reaction proceeds, remember that we were releasing 2 moles of ammonia and 10 moles of water for every mole of barium hydroxide. Very endothermic. So I've got this little block of wood here with some water on it. I'm going to show you how endothermic it is by putting this, it's all mixed up. It's a nice slurry now with all that water's been released. I'm going to stick it on that block, and I'll come back to that in a moment and show you just how this barium ions in me, because the enthalpy is favorable either, so this thing should be getting pretty cold right now. That is it. So that block it's so cold that it froze the water that's right onto the block. And that's actually goes right onto it. Not gonna let go, that's why it'll break off. Actually, so there. Yeah, so there's a little chunk of ice. I don't know if you can see it from where you are, but there's some ice on the bottom of this thing. So that.
Alright, so there's your example of an endothermic reaction. You can see that an endothermic reaction produces a cold temperature. Alright, last slide, or last indicator, is a color change. And in some reactions, a color change can indicate a chemical change if the color produced is not a blend of 2 of the colors involved, but a whole new color that wasn't there to begin with. This one's a little bit of writing. We know that a mixture of color is a physical change, so this is not, we're not talking about mixing 2 colors such as yellow and blue to get green. We're talking about a whole new color showing up as part of the chemical reaction. And I'll show you an example in just a second. Let you write for a minute. Alright, I'm going to go ahead and show the example. Please feel free to hit pause if you need to keep writing. And your last example for color change.
Now we've got enough peroxide still left. You can see it's decolorizing straight away. That's pretty cool. So what's happened now, I didn't wash the thing out properly. We had some peroxide left. And now it's reacting faster than we can add the permanganate. That's pretty cool.
Alright, so in this case you could see adding a purple and a clear mixture. When you react those 2 substances, the purple immediately turns back to clear. So that's what we're talking about. you know, a whole new color being produced. You can tell that there is a chemical reaction going on. All right? And you can go ahead and glue your notes on page 51 of your notebook.